Alright, this video is to help you become familiar with dial calipers. Now, all a dial caliper is a ruler with some attachments on it. And those attachments allow you to take very, very precise, very exact measurements. Now, in rough woodworking, we're used to measuring to the nearest 1/16 of an inch. And our measurements usually aren't perfect. They usually don't need to be perfect. For example, this birdhouse, nothing on here needs to be perfect. Nothing on here is perfect. There's a gap in the roof. This guy is not perfectly straight. This peg is sticking out a little too much, and that's perfectly fine. We don't need to be super precise with a project like this, right? It's for birds. It's okay if it's a little wrong. However, not all projects are like that. For example, I have here a 3D printed peg and then a box with a hole in it. 3D printed the peg. I measured it with a ruler, and the ruler said it was 3/4 of an inch in diameter. So I went in, I designed this guy, I made the hole 3/4 of an inch. I actually made it a little larger than that. You need to do that because if they're the exact same size, they won't fit. But if the hole is a little bit bigger than the peg should slide down in there. So I made this hole a little bit larger than 3/4 of an inch, printed it out, but unfortunately, this peg does not fit in there. Now, why is that? Well, when I measured the peg, it didn't actually read 3/4 of an inch. On this ruler, yeah, it's 3/4 of an inch, but in reality, it is 0.785 inches. 3/4 of an inch is 0.75 inches. This is actually 0.785, so we're about 0.03 inches off. It doesn't sound like much, and it's really not. 0.03 inches is the distance between here and here. So we're not off by much, but because we weren't precise with our measurements, our project didn't work out. So when you need to take very precise measurements, you need to use a precise tool. In this case, we're talking about dial calipers. Next, we're going to go over the different parts of the dial caliper, their names and their function, or how they're used. Let's start with my favorite part. This right here is called your thumb wheel. You put your thumb on it and you push and pull it, and that moves all the stuff around the dial caliper. Now, the important stuff. Let's start with these guys. You'll use these most often, probably. This set of, see how it looks like a dinosaur's mouth? These are called your jaws. These guys are different than these guys. Specifically, these guys are called your outside measuring jaws. They're used to measure the outside of objects. So if I wanted to measure the height of this cylinder, I'd place the cylinder in between the jaws. I would push my thumb wheel with my thumb to clamp the object in between those jaws. Now, to get my measurement or my reading, I'd have to look at two things. I'd have to look at these numbers right here. This is called your scale. It's sort of like the ruler, but it's called the scale. And I'd also have to look at my dial. There's numbers on there as well. Now, what if we needed to measure the diameter of this hole? Well, there's a good tool for that. These are your outside measuring jaws. These guys are opposite to outside, right? They're facing the opposite direction. They're angled differently. These guys are called inside measuring jaws. They're used for measuring the inside of objects or holes. To use these guys, you are going to place the jaws inside the hole, draw the jaws apart with your thumb wheel until it's touching both sides of your hole, and then you look at the scale, you look at the dial, and you would get your reading. Now, what's kind of cool, the distance between here and here is the same as the distance between here and here. Next, the last way we're going to talk about to use a dial caliper to take measurements is with this peg down here. Now, this peg is called your depth blade. You can see it extends all the way out of the calipers. If I wanted to measure the depth of this hole, how deep does it go? I would take the depth blade and I would extend that blade out a little bit longer than I think the hole is. Then I would place that depth blade in the hole and I would push the calipers until the bottom of the calipers hit the top of my hole. Now, the distance between here and here is the same as the distance between here and here, and here and here. And how did we read these things? Well, we looked at the scale and then the dial. Pretty neat. Now there's two more moving parts we need to deal with. We have this screw right here. Now sometimes, especially with cheap dial calipers, you'll find that when you close the jaws, right, there is no distance between these jaws. There's 0 inches. So that dial should be pointing to 0, but it's not. And sometimes that happens with cheap calipers. To fix that, double check that there is nothing like caught in between the jaws. You can take a rag and clean it off. Sometimes there's like wood chips or metal chips that get caught in there. So make sure the jaws are clean and that they are closed all the way. And then you can actually move this dial, but you have to unscrew this screw. This is called the dial adjustment screw, or the bezel nut. I just call it the dial adjustment screw. When you untighten it just a little, like a half turn, you can now move this entire dial. And we want to make sure that this pointer right here, this is called your indicator. You want to make sure the indicator is pointing to 0 exactly. If it's not, then all your measurements will be inaccurate. And then go ahead and tighten that dial adjustment screw so that this no longer moves. Yikes. Okay, there, we're good. Yeah, it's not moving. The last moving part on the dial caliper is this guy up here. You've probably messed around with dial calipers and tightened this guy down, and then you're like, I can't pull the jaws apart, my calipers are broken. Well, actually you just figured out what this screw does. This is called the clamp screw. The clamp screw clamps the jaws where they're at. So if they're closed and you tighten it, they will stay closed. It's going to be extremely difficult. You'll probably break the calipers before you get those jaws open. Now if that happens to you, you're going to unscrew the screw just a little, like a half turn. And now they should be able to move freely. But why would you need that? Well, sometimes if I'm taking a measurement on an object, I get my reading, I look at my scale, I look at my dial, I'm not going to remember it, right? By the time I get to my notebook, I might forget it. So what I can do is take this clamp screw, tighten it, and when I do that, I can even take this object out of the calipers and I can carry it, I can put it in my pocket, and you know what? The reading is going to stay the same, right? It's not moving at all, and that's because I tighten my clamp screw and my jaws can't move. So once I've got my reading and I need to take another measurement, or I want to close the calipers, I'm going to unscrew it just a half turn, and now I can move my jaws. Alright, that's pretty much it.